Hello and welcome to NASA Science Live, an opportunity for you to come behind the scenes and to get to know your space agency. I'm your host, Sophia Roberts. This show really is all about you being able to interact with NASA scientists and to get your questions answered. So visit us on Facebook or Twitter and ask us a question using that hashtag AskNASA, or leave a comment or question in the comment box wherever you're watching this. So here to share some of the latest updates from around the galaxy is our cosmic news anchor, Scott Bednar. Scott, what have you got for us?
Thanks, Sophia, and hello, everybody. I am your cosmic news anchor, Scott Bednar, and we've got some breaking news just in. Are you good at counting rocks? Well, then you won't want to miss out on this opportunity. Just announced moments ago, NASA is inviting you to help find the perfect spot on asteroid Bennu where the OSIRIS-REx spacecraft will collect a sample. But here's the problem. There's a lot of rocks. So we need your help to count, catalog, and create a curated collection of rocks on the asteroid by July 10th. Why? With your mad counting skills, this data will speed up the process in developing Bennu's hazard map, which will be used to select the final sample site. And then OSIRIS-REx is going to go down to Bennu, sweep up some little samples of asteroid bits, and send them back to Earth. All you have to do is look at pictures of this asteroid and tell us what you see. Too long didn't read? NASA is hiring rock counters for an annual salary of $0. Sign up today. It's time to tighten your Van Allen belts because we're going back to the moon. And guess what, Apollo? Your twin sister Artemis is in town, and she's here to stay. NASA's next mission to the moon with humans has officially been named Artemis, after the Greek goddess of our nearest celestial neighbor. And when we land in 2024, the first woman and next man will step foot where no one has ever been before, the moon's south pole. There'll be something for everyone. Boots on the ground, flag planting contests, rock chiseling competitions. It'll be a regular rom-com. Have you ever been to Mars? No? Well, here's your chance. Sort of. NASA is sending a car-sized rover to the Red Planet next year, and your name gets to be passenger in teeny tiny letters. Submit your alias, and it will be stenciled on a microchip that will travel on the rover as it makes its Martian debut. You'll amass mucho frequent flyer miles and get a boarding pass. You can print it out in full CMKY glory, post it on social, slap it on your locker, tack it on your tack board. The possibilities are limitless. It's absolutely glorious. Well, I'm done. But that was just a taste of space. Hungry for more? There's a full-on brunch buffet at www.nasa.gov. Go feast on some science. Back to you, Sophia.
Thanks, Scott. I've already got my name on it, and all of you guys should too. Nearly 1 million people have already submitted their names, so go send yourself to Mars. All right, let's get on to today's topic. We're going to be talking about storms across the solar system, and we're going to start by talking about how storms form on Earth, and then we'll see the conditions that cause them to happen on other planets in a weather forecast from across the solar system. And finally, we're going to take a look at how NASA studies storms on our own planet. And you guys, we're even going to release a weather balloon live during this episode. So if you want to learn more about NASA's effort to study hurricanes, visit nasa.gov/hurricanes or visit NASA Hurricane or NASA Rain on Facebook and Twitter. So our friends over at NASA Wallops Flight Facility in Virginia help forecasters and first responders with severe storms by releasing these huge balloons every 12 hours. All right, Chelsea, can you hear me? What are you doing over there?
Hey, Sophia. Yes, I can hear you loud and clear. So we're here live at NASA's Wallops Flight Facility, where we're going to take you on a behind-the-scenes look at how weather data gets turned into the easy-to-read forecasts that you get on your phone's weather app. So we're going to be launching a weather balloon today. So as the balloon ascends up into about 100,000 feet in altitude, it's going to be taking measurements. Here to talk to us a little bit more about that today is Adam Thomas. Hey, Adam. So what do we have going on behind us here today?
Well, behind us we have a balloon inflation shelter, and Kyle Pilchard, one of our meteorological technicians, has inflated that balloon, and hopefully we'll be able to release it at the end of the show today.
And so what kind of data is it looking for? What do you have in your hands here?
Well, I have a radio sign which we attach to the balloon, and it has all kinds of meteorological instrumentation here, temperature sensor, humidity. It also is GPS tracked, so we get wind speed and direction from this device as it ascends through the atmosphere.
And so about how often does NASA launch these things?
We do it twice a day here at Wallops, twice a day, every day. And in some instances, we actually do it more than twice a day. If we have hurricanes, severe weather outbreaks, National Weather Service Program will ask for more balloon releases. So sometimes we have up to 4 balloon releases a day, especially for storms such as Maria and Florence just recently, where we had to get more data and more up-to-date data with those extra balloon releases.
Wow, that's so interesting that this happens right here. Well, it sounds like we need to get this radio sonde attached, and we got to get this balloon up ready for flight. But in the meantime, if anybody has any questions for Adam here, be sure to send them to us on social media using hashtag AskNASA, and we'll get them answered a little bit later in the show. So we've got a balloon to set up. So Sophia, back to you.
Thanks, Chelsea. I am so excited about this balloon, and I'm really looking forward to it being released later on in the show. So today I have Dahlia, who is a research scientist at Goddard Space Flight Center. And Dahlia, let's just, come back down to Earth and talk about something we're a little more familiar with. How do storms form here?
That's right. So tropical cyclones is actually the catch-all term, but they're called different things depending on where you live. So for example, in the Atlantic or Eastern Pacific, we call them hurricanes. In the Western Pacific, we call them typhoons. And in the Indian Ocean, we call them cyclones. Now you need about 3 different ingredients for a storm to form. You need really warm ocean water. You need to have some pre-existing storms, and then you need really humid air. So what happens when a storm forms is that humid air starts to rise. And as it rises, there's more air that comes in to fill it inside. And so we start to have warm air rising. You get a lot of convection, which causes clouds and precipitation. And that movement inward, upward, and then outward starts the storm moving. But because the Earth rotates on its axis, that actually causes the storm to rotate, like we see the eye wall, an eye of a storm. And so because that strong pool of warm water is starting to fuel the storm, just like gas fuels our car. As the storm begins to develop, it starts moving faster and faster with stronger winds and more rainfall. And so what we see from space is we can get a view of how these storms are moving and changing, all depending on where the winds are blowing and how warm the surface of the ocean is.
All right, great. Well, we already have some questions for you. So can you tell us, what is the biggest hurricane we've ever seen?
Well, we've had satellites and before that instruments on the ground measuring this for a long time. But the most intense storm we ever saw is Typhoon Tip, which occurred in the Philippines, and it was 1,300 miles across. That's humongous. It was not only a Category 5 like we think of here, but it was a super typhoon with sustained winds of over 160 miles per hour.
Whoa.
I know.
I know. A follow-up question for that is, how damaging are these storms?
Well, so the damage, a lot of the damage is caused by winds, which is what's happening in the eye wall of the storm. Those winds are whipping around in the middle. The eye is actually very calm. But as you get further out, the winds are important, but the rain and the rain bands around it tend to cause a lot of the flooding that we see, as well as the storm surge that pushes that water onto land when it makes landfall. And so it's important to forecast and understand how these storms move and intensify so we can really understand how they're going to impact people once they hit land.
Whew, that's a lot to digest right there. And then just one very quick question, because we talked about sort of like the width maybe a little bit, but is there anything unusual about like heights or like how high up they are?
Sure. So as these storms this air starts to rise, we're able to see 3-dimensional profiles of storms all the way up to 15 kilometers in height. That's high, way higher than where planes fly. And so, with satellites like the Global Precipitation Measurement Mission, we can actually see 3-dimensionally through the clouds all the way up in the atmosphere how the storm is distributed in terms of its heavy rainfall. And that's really important to provide clues to forecasters to understand where these storms might go and, importantly, how intense they might be.
All right, thanks, Dahlia. And we'll be getting back to you a little bit later.
Great.
You may have heard of Jupiter's Great Red Spot. It's only the largest storm in the solar system, but there are actually a lot of other really unusual storms in our solar system and even beyond that. So NASA's chief scientist, Jim Green, is going to take us on a tour of some of these storms in our cosmic neighborhood. So let's find out what is happening over at what's happening over on Venus, Jim?
You know what? I can actually tell you something that's happening on Saturn right now as
great.
we wait for Jim. So one of the exciting things that we can do with the Cassini spacecraft is we are actually able to see lightning and even hear it on the surface of Saturn.
Whoa.
And so the way that we can do that is we actually see the visible light at night. And the storm, it's called the Great White Spot, sort of like the Great Red Spot, is actually so wide, it's almost as large as Earth, 6,200 miles across. But what's unique about these big gas giants relative to Earth is that on Earth we have warm water heated from the sun that causes and fuels these storms like heat engines. But on these big gas giants, we actually think that the internal heat is fueling these storms themselves. And
Like from their core?
well, just from the heat from when they were born. And so we're still learning a lot more, and some of NASA's missions, that are flying right now as well as in orbit, are going to tell us more about how these storms form, not just on our planet, but all over the galaxy.
Ooh. All right, here's another question from Facebook. And
Yeah.
Krista is asking you, what is it like to work for NASA?
You know, it's one of my favorite questions because we work with amazing scientists and engineers every day. And so one of the really exciting things about working at NASA is we have lots of exciting satellite images and information that brings us to model these phenomena on Earth. So what I do is I actually use satellite data from NASA and our partners to model landslides and other natural disasters on Earth. And these provide important information to emergency responders and other groups that are helping to understand, mitigate, and ultimately recover and build resilience for these types of disasters. And so it's been really exciting, and I think important to note that all of NASA data is free and open to the public, and that provides an important set of information for us to really understand and move forward with contributing to understanding disasters around the world.
I mean, it's really wonderful that this data, which is, created for the public, is available just absolutely publicly. So
That's right. And I think, another really important thing is that we work very closely with our partners. Mm-hmm. And so, we work with groups like NOAA, which provides operational forecasting for National Hurricane Center, for example, or the Joint Typhoon Warning Center, or the Air Force, all of whom provide operational forecasts. And so by being able to have information like, this hurricane here, where we can really understand layer by layer through the storms how and why these storms are developing. So I know this is kind of a fun tool, but what it really is showing is the three-dimensional profiles of these storms. So the colors below show rainfall, but at the top we can actually see snow at the top of this hurricane. The first time we've ever been able to do that. So information like this is really important to bring into forecast models and help us to better predict the trajectory, the intensity, and the impacts that these storms might have later on. But we can't do it alone, and our partners are critical in advancing our understanding.
All right, thanks, Dahlia. Mm-hmm. And it looks like our chief scientist, Jim Green, is now available to give us our weather forecast. So, Jim, what's happening on Venus right now?
Thanks, Sophia. I'm dying to tell everybody about some of the weather in our solar system, and it can be extremes. Let's start with the inner planet, Venus. Now, Venus, beautiful set of clouds. We cannot see the ground because the clouds are so dense, and they're moving rapidly around the planet. In some cases, they're more than 225 miles per hour. These are really rapidly moving around the planet. But what about the surface? Let's go down to the surface. Here we see the global surface of Venus, where the reds are the highs and the blues are the lows. And so you can see huge variations in altitude. But one thing to remember is the temperature on the surface of Venus is nearly the same everywhere on the near side, but also on the far side. So both the night and the day side. And that weather can be extreme. We're looking for lightning. We haven't seen lightning on this planet yet, but the temperatures are enormously hot. More than 800 degrees Fahrenheit, hot enough to melt lead. In addition to that, the pressure is enormous, 90 times our own pressure. Well, let's move further out in the solar system. Let's take a look at the weather on Mars. Mars is this beautiful red planet we hardly see any clouds. We can actually look through the atmosphere of Mars right down to the surface. But what is the surface weather like on Mars? Now, everybody has seen the movies, and in the movies, like The Martian, you see the huge dust storms, the extremes that they thought Mars was like. But it's not like that at all. The dust is really wispy. It's really high in the atmosphere. And here you see a before and after global dust storm occurring on Mars last year. And it lasted for about 3 months. And when that dust settled out and fell onto the ground, it coated many of the surfaces. We now have observed another spectacular phenomena on Mars, and that's these dust devils. These dust devils swirl around atmosphere. These are spectacular atmospheric phenomena that we had to get down onto the surface and really experience before we could believe it. Well, our lander, InSight, actually has a weather capability. It has a weather system. It measures the temperature and pressure on the surface of Mars. And that variation in one day can be more than 175 degrees. It's a huge variation, but it's mostly below zero. In fact, the average temperature on Mars is about 85 degrees below zero. So bring your winter coat. It's really cold on Mars. Well, as we go further out in the solar system, let's look at the weather on this planet, Neptune. Neptune, which is in the outer part of our solar system, is what we call an ice giant. It's a fabulously beautiful planet, 10 times the mass of our Earth. And when the Voyager 2 spacecraft flew by Neptune in the late 80s, it saw this beautiful dark spot. But that spot faded away over the years. But just recently, a new one has appeared. That one has appeared in the northern hemisphere, and you can see it in the top part of the Hubble observation in 2018. Now, this is a spectacular hurricane. This dark spot has winds that are more than 600 miles per hour, and around it the clouds are moving more than 1,300 miles per hour. Wow, the most brisk winds in the solar system are on Neptune. Well, what is it like here on Earth? Sophia, let's talk about hurricanes on Earth.
All right, thanks, Jim. And I think our friends over at Wallops are ready to release their weather balloon. So Chelsea, how's it going over there?
Hey, Sophia, and welcome back to NASA's Wallops Flight Facility. So it seems like we've got our radio sonde attached, we've got our balloon fully inflated, and it's just over here, ready for flight. But before that, can you tell us a little bit more about what we're about to witness today?
Well, we've got a beautiful day for a balloon release here at Wallops. We're going to see the balloon release here in just a minute or so. And as it ascends into the atmosphere, we're going to see it go through the troposphere and then eventually into the stratosphere before it reaches about 100,000 feet or so. And that's where we'll see it pop, and we'll start to see it come back down. But we're going to get a lot of data from that, so it should be very interesting.
And so other than sending this information to the National Weather Service, what else is this data used for?
Well, here at Wallops, we do a lot of orbital and suborbital launches that require us to do balloon releases during the countdown. That provides a safety group here with a lot of information, a lot of meteorological data is given to them during these releases. So we'll do about one balloon an hour during the countdown, and then as we get closer to T-0, we'll actually go to about every half an hour. So they have a lot of information to determine if we are go or no-go for launch.
Wow, so how many launches does that end up being altogether for a launch?
Generally, we can do as many as 10 or 15. I think with the last resupply mission to the space station, we actually did 15 balloon releases throughout the countdown. So the meteorological technicians are very busy.
Well, hey, speaking of launches, are we about ready for this countdown?
I think so. Let's get to it.
All right, is everybody ready? Let's get going. 5, 4, 3, 2, 1. There it goes. So as this balloon ascends, what does the data look like as it comes back to you?
Well, the first data that we get back in the weather office is in the form of what we call a skew-T diagram, which provides us with a lot of temperature and dew point information up through the profile, also wind speed and wind direction. And we look at that diagram to get basically an overall assessment of the atmosphere. So if it's a stable atmosphere like today, or sometimes we have an unstable atmosphere where we can have thunderstorm activity, that's a very important part of our diagnostics that we do for weather forecasting.
Well, it seems like we're almost ready to take NASA social questions, but before that, I have a quick question for you. So it seems like this is a ton of data that we're getting back, but does this paint the full picture for weather?
Not entirely. We do have this radio sign information going into the computer models, but this is all sent to the National Center for Environmental Prediction with NOAA. In addition to that, we have NASA satellites. We also have NOAA satellites with their GOES and POES satellites. We also have surface observations, radar data that are all included with that data set. So it's a big collaboration of data, but the balloon is really our highest resolution data that we get. It gives us data back here at Wallops every second as it's ascending into the atmosphere.
Wow, thank you for answering all of the questions that I had. But I think it's about time that we take some audience questions here. I wanted to remind everybody that if anyone has any questions for Adam, to send them over to us on social media using hashtag AskNASA. Let's take a look at what we have here. So it looks like our first question is from Twitter, and who wants to know how big is the balloon?
Well, as you can see, when we just released it, it's about 6 feet in diameter. But the interesting part is when it goes up into the atmosphere, the pressure drops. So the balloon actually expands as it goes up in height. So on a successful launch, if we get it up to about 100,000 feet, the balloon will expand to about 20 to 25 feet in diameter, or as big as a small building in some cases before it pops. So it gets very large as it ascends in the atmosphere.
Oh, wow, that's really cool. So we've got another one here from Facebook, from a Facebook user, Katie, who wants to know, do balloons take off in other places?
Yes, actually, we're one of about 92 sites in the United States that have a balloon program with the National Weather Service. So we do 2 balloon releases a day, but here at Wallops, but in other sites, they also do 2 a day to really have a full scope of data coming from the entire country. And throughout the world, we have many, many balloon releases as well. So it's very important data that gets fed into our computer models that we as forecasters use every day.
Okay, we've got some good ones coming in here from Twitter. How much mass can a balloon carry?
Well, it doesn't need to carry much. That radiosonde is very light. So as it goes into the atmosphere, it ascends and brings that instrument into the atmosphere, into the stratosphere, actually, to about 100,000 feet. So it really doesn't have much weight hanging from the balloon.
Very cool. So we've got another one here that asks, can we see weather balloons from space or from airplanes?
You can see them from airplanes, but one thing that we definitely want to make sure of when we do release these balloons is to get clearance to release the balloons. We don't want airplanes flying by as we release those balloons. We do not want them going in through the engines of these airplanes. So definitely want those cleared out of the way. You can see them from an airplane, but they know when we're releasing balloons that they don't run into one of them as they're ascending into the atmosphere.
So it's not very likely that we'll ever see one looking out the windows of our airplane?
Not very likely. Not very likely. If so, it'll be at a distance.
So another person wanted to know how high does the balloon travel and where does it collect the data?
So about 100,000 feet is generally where we are satisfied with the balloon. We have gotten balloons as high as 115, 120,000 feet. The requirement is about the 400 millibar level. If you go below that and you have a failure, then we have to do another balloon. So that's the level that they needed to get to in order to be successful.
That's really cool. Well, thank you, Adam, for joining us and answering all the questions that we had online. I think that's just about all the time that we had. We hope you enjoyed seeing our balloon. We're going to be doing it again this evening, right?
That's right. Yep. Every night.
All right. Well, thank you so much for joining us here at Wallops. Back to you, Sophia.
Thank you so much, Chelsea. It was really cool to see the balloon being released. But we're also here back with Dahlia. So we're going to go back to some Earth storm stuff. So can you tell us how we study storms with NASA?
Sure. So NASA and our partners, we have a lot of different assets that are allowing us to look at storms both in the tropics and up to the poles. We have satellites like the NOAA-NASA GOES satellites. That's at 22,000 miles up and take a view of the Earth all at the same time, being able to look at the top of the clouds and the temperature. Further down, we can start to look at how the storms are distributed. We talked about GPM a little earlier in the show, but we have other satellites like the Cygnus constellation, which is super cool. So we can look at global precipitation using GPM and other products that tells us about not only rain in the tropics, but all the way up to the poles. And satellites like Cygnus have a constellation that actually uses GPS signals bouncing off the surface of the ocean to tell us about wind speeds in these storms.
Wow.
Yeah.
And I'd also mentioned earlier, but the data is helping first responders. So can you also talk a little bit about that?
That's right. So being able to understand the impacts of these storms, the first and most important thing is about forecasting them, right? So NASA provides research, and with our partners at NOAA and other centers, we can provide accurate forecasts, or they can provide forecasts of where storms are going. But there's other satellites up there and airborne information that can provide us about how these storms may impact people. For example, we can look at how vegetation changes as a storm passes over. So this is an example of, we can see before and after Hurricane Maria moved over Barbuda. And you can see literally that and the Virgin Islands, that all of the leaves on the trees in these areas were completely blown off. And that affects ecosystems, and it affects the recovery of an area. Another example of how we can understand impacts is looking at rainfall accumulation. So we talked about how the rain bands in these storms can cause a vast amount of rainfall. Hurricane Harvey, for example, caused over 40 inches of rain to fall over the Houston, over the Texas area. And that inland flooding is critical for groups to understand, like FEMA, to provide information and help when these storms pass. And also, we can look at how humans are impacted, looking at things like power outages. So from the SUMI NPP mission, this is an example of Puerto Rico after Hurricane Maria went over the island. And you can just see how the power has changed in terms of loss of power, and then we can look at satellites to see how power has been restored across the island. Really important signatures for how we can help in the recovery effort.
Yeah, that's really great that we're able to provide that information to those really useful things. So what other storms, I'm getting here, does NASA study other than hurricanes?
So as we said, so hurricanes and tropical cyclones really occur in the tropics to mid-latitudes. But we also have satellites that can go all the way up to the poles or the Arctic and Antarctic Circle to look at how these storms change from tropical to extratropical systems. And that's really important for us to understand things like light rainfall and snow and ice, these crazy winter storms, or Superstorm Sandy, where you had all of these crazy systems colliding in one place. And by being able to work with our partners and have NASA satellites and airborne assets to understand these storms, we're able to look at everything from the tropics to the poles.
All right, and one really quick question for you.
Sure.
What is your favorite thing about working here?
I love that we are able to work together every day. And, I like that we're looking towards what's happened in the past, using satellite data to understand and model the past, but we can also look at what's happening in the future. And so understanding how climate change impacts our Earth system is of critical importance.
Well, thank you so much for joining us, Dahlia.
Thank you so much.
Yeah, and that is all the time we have for today. But if you want to learn more, visit nasa.gov/hurricane, or visit NASA Hurricane or NASA Rain on Facebook and Twitter. And be sure to tune in next month. On June 26th, we're going to be talking about space rocks. We're going to discuss how NASA detects and tracks asteroids, and visit a DART spacecraft being built, and even more. So please tune in June.